Hi, in this video I'm going to be talking about creating output from EnRoute and then ways to visualize the output, particularly as part of driver creation and debugging and all that sort of thing. So the first thing I'm going to do here is I'm going to create something very simple. So I'll create the word design here and maybe modify it just a tiny bit, and then I'm going to add toolpaths to it, and it just tells me that it's going to convert the text to curves, and I'm going to add a tool in this case. So if I clear the tools here, I can choose the tool that I want to use. So then if I double click on 1/4 inch in mill and give it a depth, and we'll give it 4/10 as a depth, I can of course come in and edit parameters, but there's other videos that describe how to edit the parameters. Okay, so I create the toolpaths, and you see the toolpaths here are offset from the geometry, of course based on the tool diameter, and so that's the way to identify the toolpaths. And start points are shown here. I could have added entry, exit. There's lots of things I can do with the toolpaths, but once I have them, then there's ways for me to visualize what they're going to look like. I can do a 2D, so I can actually draw the toolpaths one segment at a time this way, or I can go from tool lift to tool lift, or tool change to tool change, or I can go all the way from beginning to end. So that's a 2D. I can do an orthographic, meaning in the 3D view here I can do a sort of an animation of the toolpaths. Sometimes that's handy when determining what tools it's going to use, tool order, that sort of thing, just to make sure that the toolpaths look like they're doing the right thing. And then I can do a 3D simulation. Here I'm going to choose material color and the color of the cut area, and so I can use a select color and pick a color for that. I can choose to animate it, and so we'll see what that means here. So it creates a solid here that I can view in a rendered view, and then I can see the cutting that it's doing. That's what the animation, so when I choose to animate, that's what it does here. And I can speed that up and slow it down. So I can speed it up by using the arrow keys. If I use the right arrow key, you can see I can speed up the drawing of that. And so that's within EnRoute good ways to look at what the toolpaths are going to do. So now we will sort of compare that with what it looks like when we output the toolpaths. So now of course we're going to output the toolpaths, so I'm going to choose to output. I'm using the multicam GC driver here. There's a whole bunch of ordering options that I can choose. Again, there's other videos that describe that. But once I decide that I'm going to output, I choose to send it to a file, and I'm going to call it design1 again here. So it creates the output, puts it in the folder that I want, and so now basically what has happened is EnRoute has created the PCD, or the P code file, which is the file that it creates every time. It has then activated the PT, which then utilized that driver to translate the code into the appropriate, in this case, G code for the output. And so now what do I do? So I can now come in here and open a program called Backplot, and this is another EnRoute program, and we can visualize the actual output. So come in here and we will open it up and go to the DNC files in the test folder. You see I have design1 there. So now here's a representation of the actual output. So this is the the CNC file, which is the extension used for this driver, and here's all of the code in the file, and then the depiction of that specific code. So here you see that it's not showing geometry, it's showing the actual tool paths. So if I switch back to EnRoute, you can see that in the corners the offsets are rounded with arcs, and so now if I look at it in backplot, you see those arcs are drawn here. In this case, arcs are represented by red lines and lines are represented with blue. And the nice thing about this is there's lots of things I can do. I can go into what's called a step mode, in which case I can actually step through the code and have EnRoute draw have backplot draw the actual segments as I pass them in the code. So this is another nice way to not only visualize what's going on, but also to be able to debug if something odd is happening in an output file or something maybe unexpected is happening, to see what's going on in that view. I can also, while I'm doing it, I can hit Control-Alt-P. I can switch to a perspective view. I can zoom in and zoom out as I'm stepping through the file to sort of get it to display what I want to display, and to look specifically at the area I want to look at. So the step mode, you can see I can go in either direction. I can go right exactly where I want to go to see where I'm at. So it's a really handy tool for drawing the actual commands, the actual, in this case, G-code commands, and seeing specifically what's going on at a specific location. If I click on the drawing, it'll go to the line of code that creates that area. So again, it's a really handy way to visualize what's happening and to see from a debug perspective what's going on in an output file. So that's backplot. So now let's go back to EnRoute. One of the things that is often handy because I'm creating output is I'm going through this intermediate file. I'm going through a PCD file or P-code file. So if something odd is happening at the output end, the question is where did the problem happen? And so it's important to be able to see what's going on in the PCD file also. So from within EnRoute, if I hit Control Shift F11, it toggles the option of deleting the PCD file from the output folder. So now if I output this file again, and I click to File, and I'm going to call it Design 2 this time. So now when it created the output file, let's go back to backplot, and we'll go to Open. So now when it created the output file, you see now there's two of them. There's the Design 2, which is going to look identical to this G-code file that we created, but I also have the design2.pcd. So that's the intermediate file. Backplot is also capable of reading that file. And so let's turn off step mode here, spin it around. Now you see that the lifts go down, and that has to do with just the way I'm visualizing it. So I can go to Preferences here, and I can click on the Z direction, and in the multicam output, the positive Z is down, and so we want to flip that up here. And so this just gives me a way to visualize it that makes more sense. But now I'm looking at the PCD file. I'm looking at the actual output from EnRoute before it has been passed through the driver. And so each of these represents a P code. So a job parameters, message, 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 start job, roll feed. Roll feed is kind of one that's used differently than the original PCD was envisioned. It actually gives me the length of the job. No, and thickness, I believe. messages are used kind of throughout to convey other information. Set machine plane, tool change, and then each of the portions of the record or of the data structure of that P code. So a tool change gives me a target X, target Y, target Z. Spin, that's a spindle rate, tool number, and the tool name. So that's the data structure of that PCD. So this is a great way to then compare output from the PCD straight from EnRoute to the output file, which has then passed through the driver, as a way to make sure that all of the information is being utilized properly in the right order and all that sort of thing. This shows me exactly the order that the data is coming out, so that then sometimes I have to make decisions about when that gets used and what information I have at any given moment in the processing of the output file or the processing of the PCD file. And so again, I can click anywhere and it'll tell me what that is. So it's a really handy way for me to debug things that are going on in the PCD file, so I can make decisions about, for example, if there's an issue, does the issue happen from EnRoute to the PCD? Does the issue happen in EnRoute? Does the issue happen as the information is being translated from the PCD to the output file? So backplot is really a vital way for me to debug a driver and to make sure that I understand what's going on in EnRoute, and then coming out of EnRoute, and then going from the PCD to the output file. So that's a pretty quick illustration of ways for me to visualize information, visualize design information, going from here, what I anticipate it's going to look like. So I've got ways 2D and sort of orthographic, and then 3D ways to visualize what the toolpaths are doing in EnRoute. And then when I get out of EnRoute, I can go to backplot and see what that's going to look like at the PCD level, and then also at the output level. In the output file, I can look at, of course, what the format of the code is, and if that meets the needs of the manufacturer, the customer. And so from a driver creation standpoint, using EnRoute and using backplot together is really the way to make sure that what's happening is what's intended to happen and what's anticipated to happen coming out of EnRoute. So hopefully this is helpful and another step in the process.